Hi guys, this is Mrs. Seeley with a lesson on comparing and ordering rational numbers. You are going to need binder paper. Hopefully you have a math notebook, but if you don't, get some loose binder paper and go ahead and make sure you set it up with a line that's about 1.5 inches or so from the red margin line. Pause the video and get yourself ready. Okay, we are going to title our notes, Compare and Order Rational Numbers. So make sure that you write down everything that I'm writing down. So compare and order rational numbers. And I honestly don't know if we've even talked about what rational numbers are. So that's where we're going to start. What is a rational number? Now remember, if I'm going too fast for you, just pause the video and get caught up and hit play again. So what is a rational number? See if I can get that in focus there. So a rational number is any number that can be written as a fraction. So think about all those numbers that can be written as fraction. Any number that can be written, excuse the background noise, as a fraction. Remember, decimals can be written as fractions, whole numbers can be written as fractions, and fractions can be written as fractions. So let's just remind ourselves, remember, if we have this example, 0.5, remember the tens place is the first place to the right of the decimal, so it can be written as the fraction 5/10. Okay? And you could even have a negative rational number. What if we had 0.51, right? Negative 0.51. This is now going to be negative 51/100 because the two places to the right of the decimal is the hundreds place. So a rational number is any number that can be written as a fraction. So we are going to be comparing rational numbers, okay? And I'm going to call them rational numbers to save time. RN, we're going to be comparing rational numbers. And when we compare, we're going to be using the greater than, less than, or equal to symbol. And remember, you can think of the open mouth as like an alligator or something, and they always eat the largest portion or the largest number. So let's go ahead and take a look at an example. We're going to be looking at the example negative 1.2 compared to 0.8. Now, right off the bat, if you remember, negative numbers, any number further to the left down the number line is always a smaller number. So we can probably immediately say that negative 1.2 is less than 0.8. But let's go ahead and prove this on a number line. And you should pause the video here to go ahead and write yourself a number line and to go ahead and write the example. And now that you're back, I'm just going to go ahead and mark every tenth because it's too scrunched, right, to mark everything. And so now we have a negative 0.2, negative 0.4, negative 0.6, negative 0.8, and then negative 1 and negative 1.2. Okay, so we have this on our number line, and so I'm just going to go ahead and plot these numbers. Positive 0.8 is to the right of 0, and negative 1.2 is to the left of 0. And I know that anything to the left, further to the left on the number line is less than, so I'm going to go ahead and have the open mouth towards the larger value. Now we can also do this with fractions. If we had a negative 3/8 compared to a negative 5/16, I need to compare these. Now you have to think way back. My denominators are not the same. What is it that I can do so these are easy to compare? You're absolutely right. Let's give them the same denominator, okay? So I know, because I'm really got my math facts down, is that 16 is a multiple of 8. So I can go ahead and turn both of these fractions into fractions over 16. Now this first one, I don't have to change. It already has a denominator of 16. But this other one, I do have to change. And remember, what we do to the bottom, we have to do the top. So how did we get from 8 to 16? Well, we multiplied by 2. So we have to do the same to the numerator. And 2 times 3 is 6. And remember, this was negative to begin with. So it is going to be negative when we make it an equivalent fraction. Now, if you were to picture a number line, right here, we'll try and do this quickly. Now, this is just going to be part of a number line, but we'll only have the negative side, right? These are sixteenths, let's say. So this is negative 1/16, okay, negative 2/16, negative 3/16, negative 4/16, negative 5/16, negative 6/16, and negative 7/16. So I can go now ahead and plot these negative fractions on my number line. Negative 6/16 is right here, and negative 5/16 is right here. Well, which one is furthest to the left? Well, negative 6/16 is furthest to the left, so it is smaller. So we are saying that because it's negative, that negative 3/8 is less than negative 5/16. Okay, but now I have a problem for you. What if I want to compare two numbers that aren't in the same form? What if I want to compare negative 51 hundredths and negative 8/15? Well, this is a decimal and this is a fraction. What am I going to do? Again, you have to think way back when we were comparing numbers. If they're not in the same format, what do you do? I can hear you thinking, are the gears turning? You're going to make sure that they are in the same format. And for me personally, I prefer decimals. That's easier for me to see. So I'm going to go ahead and keep negative 51 hundredths, but I have to turn this fraction into a decimal. How do I do that again? Right, every fraction is a division problem. So I'm going to go ahead and take a moment here and divide the numerator by the denominator. And remember, you can add a decimal point to the right of that whole number and some zeros, so you can keep on dividing and not end up with a remainder. And that way we can have a decimal as an answer. So I'm going to go ahead and make that decimal point live right above where it is in the problem, because I don't have any decimals in my divisor. And I'm going to go ahead and divide. And I'll do that quickly here for you, but I also want you to try it. So go ahead and pause the video, and then we'll come back and check our work. Alrighty, so I've done the work here, and I'm hoping your work looks the same. And I can start to see I'm going to get myself in that endless loop of division, because I'm ending up with 50 every single time. And so I know that this is going to be 0.53333 forever. So remember, we use that bar notation and go ahead and make it 0.53. Now, again, this was a negative fraction to begin with. So we're going to make sure it remains a negative value as a decimal. Now, picture a number line. And you can see that, let's just take a part of a number line. We'll have negative 50 here, and negative 52, negative 51, 52, 53, and 54. So this is negative 51, negative 52, negative 53, and negative 54. Let's go ahead and plot negative, actually, sorry, these are decimals, my bad. Negative 51 hundredths is right here, and negative 53 hundredths is right here. Well, negative 53 hundredths is furthest to the left, so it has to be smaller. And this tells us that Negative 51 hundredths is larger than negative 8 fifteenths. So some things to remember. When they're decimals, you can plot it on a number line and it's easy to see. When they're fractions and their denominators are not the same, well, turn them into equivalent fractions with the same denominator, then it's really easy to see. And if they're not even in the same format, you can turn them both into decimals, both into fractions, whatever you want. I just happen to prefer decimals because it's easier for me to see their equivalency. Okay, so that is how we compare rational numbers. Okay, now it is your turn. You have two examples here. I want you to go ahead and pause the video and then come back and check your work. All right, my friends. So I went ahead and did my math. I hope you did your math. And what I realized is that when I turned this fraction into a decimal, I got a repeating decimal of 0.3. But I made it the same number of digits as this decimal again, so it's much easier to see. And if I were to look at this on a partial number line, only a partial, because I don't have time to write it all the way up to 35, we would have 0.30, 0.31, 0.32, and so on. 0.33, I didn't give myself enough number line. 0.34 and 0.35, and I know that 0.33 is, oh my goodness, I got myself 1, 2, 3, all crowded here. I didn't give myself enough room on 0.35. Now we're in the positive, right? We're in the positive. So the further to the right is the bigger, so 1/3 is smaller than 35 hundredths. Now again, we're in the negative on this one. And I did my math and I got a repeating decimal of 0.16. Okay, now what do? We have a terminating decimal of 0.16, but then we have a repeating decimal of 0.16. Well, that repeating decimal is different. You know, if these were positive numbers, it would be a little bit bigger, but really on this one, if we had negative 0.16 and then the repeating decimal, it would be just slightly to the left of that, just a little bit smaller because it's to the left. So we know that 0.16 is just barely bigger than 0.16. That's a repeating decimal. I didn't plan that. That's just a number I made up. So if that's kind of curious how that turned out. I hope that makes sense to you, because if I were to, let's take this idea. If I were to take this repeating decimal, 0.16666, okay, and I just wanted to round it to the nearest hundredths place, it would become 0.17. So it's going to be to the left of that negative 0.16. And so it's going to be a little bit smaller. I hope that makes sense. All right, so I needed a new piece of paper. If you need a new piece of paper, go ahead and pause your video and go ahead and get set up for this next section. We don't have a lot more that we're going to do. All right, so now we're going to order rational numbers. And again, I'm going to put rational numbers, okay? Because I don't want to write it all out. And let's see if we can get, again, that focused for us here. All right. So when we're ordering, we're ordering from least to greatest or greatest to least, okay? And we've done this before. So which one's the biggest one and so on, or which one's the smallest one and so on. So I'm going to start us right off with a kind of a tricky one. What if I have 3 numbers and they're not in the same format? Let's go ahead and look at negative 2 and 46 hundredths, and then negative 2 and 22 25ths, and negative 2 and 1/10. Oh my goodness. I've got a decimal, I've got mixed numbers. What am I going to do? I know what I'm going to do. What are you going to do? I'm going to change them all into decimals because that is easiest for me to see. And I'm going to start with the two easiest ones. 2 and negative 2 and 46 hundredths is already a decimal. And negative 2 and 1/10, well, decimals are tenths, hundredths, thousandths. So I can simply change this one into 2 and 1/10. Now, remember, I can see that these decimal places, there's two decimal places. So I'm going to annex a 0 here because I want to make sure that my decimals have the same number of digits. Now, here's the tricky one. 2 and 22 25ths. There are two ways to do this, and I talked to you about changing a mixed number into an improper fraction and then dividing. But I'm also going to show you another way. So we're going to show two different ways to solve this mixed number, okay? And I'm going to pause the video here and kind of get my writing done, and I would like you to pick one way and try it. You can keep the whole number and just deal with a fraction and turn that into a decimal, or you can turn the whole thing into an improper fraction and then divide. Alrighty, go ahead and take a look at these two methods for turning that mixed number into a decimal. This first one, I just kept the whole number. I didn't mess with it. And all I did was I took the fractional part of that mixed number and turned it into a decimal. And so when I divided 22 by 25, I got a repeating decimal of 0.8. But because I want my decimals to have two decimal places, I went ahead and made it 0.88, and I added it, attached it to my whole number behind the decimal. This side, I took that mixed number and turned it into an improper fraction and then divided. And I ended up with 2.88 with a repeating decimal because 25 goes into 72 twice, and then I'm ending up with some division that takes me to the right side of the decimal. So either way, you end up with 2.88. And remember, this was originally a negative mixed number, so it's going to be a negative decimal. And I'm going to put it in here, even though it'll look a little strange with that line through it. Okay, now I have to decide what is bigger and what is smaller. And let's go ahead and just order this from smallest to largest. I am going to draw myself a number line. And because I don't want to draw an entire number line with all of the little pieces and parts, I went ahead and I just went negative 2.10, negative 2.30, and you can see negative 2.20s, and I just skip counted by negative tenths. So if I were to graph these, here's negative 2.10, negative 2.88. This is negative 2.80, so it's somewhere out here, okay? And then negative 2.46. So here's 2.40. It's a little bit over the halfway mark. So you can see on this number line, the smallest, because it's further to the left, if this were a number line out here, 0 would be over here, right? So it's furthest to the left. The smallest decimal is 2.88. And so that is this mixed number 2, negative 2 and 22 25ths. The next one is 2.46, negative 2.46. And then the largest one is negative 2 and 1/10. You can see that I took my original numbers and put them in order. I used turning them all into decimals as the way for me to figure that out, but I definitely want to go ahead and use my original numbers when I go ahead and write them in order. All right, so now I'm going to have you try one, and I'll try and keep these numbers fairly friendly so you get some good practice. All right, I took a big pause here, so I don't remember what I said last. Here is your turn. You're going to order from greatest to least, and it's from the biggest to the smallest. These are all negative, and this is where it gets tricky figuring out which one is smaller. And we have two fractions and a decimal. Go ahead and do the work. Choose whether you're turning it into a fraction. They're all fractions or they're all decimals, and then come back and check. Alrighty, so I went ahead and changed everything into a decimal. I went ahead and brought down negative zero point 0.6 and annexed to 0 because when I was doing my division, I got a repeating decimal, and it really helped me to just go ahead and make sure that they had two digits. So 2/3 is 0.66 repeating, and 4/5 is zero point 0.8. So again, I annexed to 0. I plotted them. I'm going to plot them on a number line. So we have 0.60 here. We have 0.66, which is about here. And then we have, oh, I'm sorry, negative. I'm in the negative. It's negative zero point 0.8 here. So remember, if we had a number line that was way out here, this would be 0 because negatives are to the left of 0. So we're going from greatest to least, the largest one. So that's the one furthest to the right. So 0.60, this is the largest one, okay? And then working our way down, negative 0.66, that is now in the middle. And then negative zero point 0.8, that is the smallest. So there you go. I hope that you got some good practice in there, and we will practice tomorrow in class. Be ready.